class. Before I actually go and review this question, which is based on what we had learned on Tuesday about conic sections, I just want to remind you that I posted on Blackboard something that looks like this. It's called the Study Guide for Math 136. And what it does is it goes through each chapter of the book in terms of the topics that we are required to know, with some worked out examples and then some examples for you to try. There, in addition to that, I posted a answer key for it so you can check your answers. And it's a good way to study for the final because it goes through each topic. If there's a formula that you have to know on the topic, it gives the topic. You don't have to go through the whole book or all your notes. This is a good way to study. Of course, if you see there's a topic in the study guide that you're not familiar with, that's either go back to the recordings of the class of that topic, because each recording is listed with its date and the topic that was covered that day. So you can go back to the recordings, you could go look in your textbook, or you can, of course, ask me. Now, I understand that Shireen is no longer available this term. Something came up and she can't handle it anymore, but there are other tutoring sessions available. And again, I posted that, just like I posted this on Blackboard. I posted this, I think, in the weekly, in your weekly section. Just look at that, but I also posted in the information section, or I'm not sure, I posted something that I got from math department as to times of tutoring specifically for Math 136. So that's something you could look up again. That's something that you should look. It's at this point, the Blackboard account has been filled up with a lot of things, and there are a lot of resources there for you to use to study for the final. I think the final is going to be on I think it's on either December 13th or 14th, but it's that week of the just looking at the calendar. Sometime the week of the 13th, of December 13th. During that week is our final. So be aware that the final is coming up. We are already on class number 23. We have a total of 28 classes, the 14 weeks, the 15th weeks of the final. So again, this is a good study guide, and there are various other things that you can use to study from. Again, if you have any questions, you can always either bring them up in class, or I am available. Anybody who's gotten on early sees that I here from like 9:25, 9:30. And if you need me to be here earlier than that, you just have to email me. Or if that time doesn't work for you, you can email me and we can work on a mutual time for us to review any particular topics that you would like me to go over with you. But I hope to finish a little bit early so that we can do review questions for the final. The final, don't forget, covers the material from the beginning of the year. Everything that was on the midterm, plus whatever has been taught since the midterm. Okay, so let's look at this problem here. It says put in standard form and then graph 25x squared plus 4y squared minus 100 equals 0. Now, before I do any work on it, I want to think to myself, what kind of shape could this possibly give me? So I see it's definitely a quadratic equation because I see x squared and I also see a y squared. So I know it's not a parabola because the parabola doesn't have a y squared. This has an x squared and a y squared, but the numbers in front of the x squared and the y squared are different numbers. The coefficients of the x squared and the y squared are not the same. They're not both 1. So that must mean that this is an ellipse. And the way we put an ellipse in standard format is, first of all, we leave just the 25x squared plus the 4y squared on the left side and bring the 100 to the other side. So we have 25x squared plus 4y squared equals 100. And the standard format, we have to get it equal to 1, so I divide everything by the 100. And we simplify this. So the 25 cancels into the 100 and we get the 4 in the bottom. Remember, you're always left where the number is larger. So that gives me x squared over 4. And this cancels down and I get, this gives me 25 on the bottom. So we get 25 y squared over 25 equals 1, which looks much more like the way we did see the standard form of an ellipse. In this case, the a squared, the number underneath the x squared is always the a, is always called a squared. The a squared is 4, which means my a will either be plus or minus 2. Remember, the a gives us the x-intercepts. The b squared is a number underneath the y squared. Remember, it has to be in standard form to get these numbers. The b squared is 25, which means my b could either be plus or minus 5. And again, the b gives us the y-intercepts. So if we go to graph this, here, let's graph it over here. What we do is we go to our x-intercept, 2 to the right and 2 to the left to get to -2. And the y's, we go up 5 and down 5. These are our y-intercepts, so that we end up with these 4 points that we connect. And we have this ellipse, which is, as I said, an oval, a sort of squashed in circle, which has been squashed vertically. And that's what we would need to know about this particular example. All right, so let's now start looking at the examples on that we have to know from our next section. Remember, the next section we're doing is something called trigonometry, and I did post on your Blackboard account, I did post something that has to do with a trigonometry review, so you could look that over, because there is no chapter in the book that covers trigonometry. The textbook does not cover trigonometry, but I will now cover all the important material you need to know. Again, you can look at that trigonometry that's on your Blackboard account. You could also look at your study guide, which has following the section on conic sections, it has a section on trigonometry. So we mentioned on Tuesday a very important formula that applies to right triangles. Remember, a right triangle is a triangle in which one of the angles is what we call a right angle, or an angle that's 90 degrees. All three of the angles add up to 180 in any triangle. If we have one of the angles being a 90-degree angle, we get a right triangle. And we recognize that right angle where we have this little square corner. Any place you see a corner that forms like an L shape, that is a right angle. It's a little better. This looks like this really should go straight up. And if we draw the triangle, in other words, we draw the third side connecting the two of these 2 points, we get something called a right triangle. We usually label the points, the vertices A, B, and C, where the C is usually put at the right angle. Again, it doesn't have to be ABC, it could be PQR, it could be any letters you want to use. And what we said about this is, number one, we use capital letters for what we call the vertices, the corners, the angles of the triangle. And we use lowercase letters, small letters, for the sides of the triangle in a very specific way. I look at this angle A, it's right over here. If I look directly across from A, what we call opposite to A, we have this side that runs from B to C. That's what we're going to call small a. This angle B is directly across from this side that runs from A to C. So we call this side small b. And this side that runs from A to B is directly across from angle C. So this is my small c. Be very careful. Once you've put in the capital letters, the lowercase letters go in a very specific way. It's not all random. The A, B, and C could be random, the capitals, but once you have placed those capital letters, the small letters go, as I said, directly across. Now, in this triangle, side C happens to be across from the right angle. In the right triangle, the side that's across from the right triangle is called the hypotenuse. We mentioned all this last time. And the other two sides that are across from what we call the acute angles, the smaller sides of the triangle, are what we call legs. These are their two legs. And what we did mention was this very important formula called the Pythagorean Theorem, that a squared plus b squared equals c squared in any right triangle. As a matter of fact, that's a proof that you have a right triangle. If you have a squared plus b squared, the two smaller legs, when you square them and add them, will give you the hypotenuse squared. And of course, we can have a question that has to do with that. So let's say I gave you this. I get a picture that looks like this. This is right off of the final exam, where this is written A, B, and C, just like our triangle. And we're told find C when A equals 5 and B equals 12. Now I'm going to give you a few minutes to do this while I take attendance. Jesus Antonio. Good morning. Jackson Avila. Good morning. Tiffany. Tiffany.
I'm here. Good morning.
Good morning. Kayla Brantley. Tashana Caesar. Good morning. Dion Carter.
Good morning, Professor.
Hi, how are you?
I'm okay, thank you.
Great. Wensley Charlemagne. Tatiana Collins. Good morning. Awa Diallo. Good morning. Ashay Douglas. Hi, good morning, Ashay. Ileana, I'm sorry. Good morning. Emily Gomez. Anastasia Guerra. Zanabu Hamad. Ismail Hassan. Ismail,
Morning.
good morning. How are you?
All right.
Great. Jaden Jackson. Okay, Paul, I see you're ahead of the game. Hi, Paul. I'll put you right down. So I won't have to call your name. Ashiana Jacobs. Good morning. Anijah John. Thomas John.
Yeah.
Hi, good morning.
Okay.
Ashley Moorhead. Angelica, I know you're here. We spoke earlier. Tayan Regest. Good morning. Akeem Richards. Good morning. Craig Ricketts. Craig Ricketts. Giovanni Rowe. Giovanni. Devonley St. Jules. Najee Waddell. Okay. That. Okay, so let's look at this. Problem. So if we look at this, we're told that A is 5. Now remember, the little a is across from the capital A, so this is where my A is, which is 5. And we're also told that B is 12. So if I look at my diagram, this is my capital B, so this is my small b, which is 12. And we want to figure out what C is, which happens to be, as we look at it, our hypotenuse. So again, I'm going to use this formula, a squared plus b squared equals c squared. So I'll do 5 squared plus 12 squared equals c squared. Be very careful when you're putting the numbers in, because if they would have, for example, given you what c is, you would have had to put it in place of the c. Be very careful about that. Don't always immediately do the two numbers squared. Well, now working this up, of course, you can use your calculator if you have a calculator. 5 squared is 25, and 12 squared is 144. So if I add those two together, I get 169 is c squared, which means I know what the number squared is, and I need to figure out what the number is, so I have to take the square root. So if I go on my calculator and I do the square root of 169, I'm going to get the answer 13. And of course, I'm only going to use a positive answer because we're talking about sides of a triangle. It doesn't make sense to talk about them as being negative. So the answer to side C is it's 13. This happens to be a special type of right triangle because most of the times when you work these things out, numbers come out to be decimals or fractions or irrational numbers, things in square roots. In this case, it came out to be a rational number, the whole number 13. It's called a Pythagorean triple, 5, 12, 13, because 5 squared plus 12 squared gives you 13 squared. Another Pythagorean triple that comes up very often is 3, 4, 5. Because if you did 3 squared, you get 9, and 4 squared is 16, and those add up to 25, which is what 5 squared is. So sometimes we recognize the numbers, but it's always a good idea to check it using the Pythagorean theorem. So that takes care of the Pythagorean theorem, but it doesn't take care of our study of right triangles, because what the Pythagorean theorem allows us to do is it allows us to find the third side of a right triangle when we know two sides. But it said nothing about the angles. The only thing we know about the angles is that one of them is 90 degrees, but we don't know what the other two are. So that's where trigonometry comes in. Let's erase some of this and just stick with our simple right triangle here. There happen to be, well, we're going to start off with 3 what are called trigonometric functions or trigonometric values.
Professor, I have a quick question for you.
Sure.
For the problem that we just finished doing, if you had given us A and B, I mean A and C, and we were missing B, would we have gone about the same way of solving the problem?
Okay, you know what, let's do one like that because it's a good question.
All right, thank you.
Before I go on to what I was saying, here's a triangle. Again, I'm going to call it ABC. And let's say I say that side A is 15 and side C is 17, and I want you to find side B. Again, of course, you would use the A squared plus B squared equals C squared. Here's your right angle right here. I'll give you a minute to try that, everybody. Okay, thank you, Emma. Well, that looks like the right answer. Let's work on it together. Again, I'm going to use this formula, a squared plus b squared equals c squared. Again, when do I use this formula? When I'm giving two sides of a right triangle and we want to find the third side. In this case, the side that we want to figure out is side B. So when I stick this into the equation, I do 15 squared, that's my a squared. B squared, I don't know because I don't know what B is, equals 17 squared. Notice I have to put in this number on the other side because it happens to be the hypotenuse. Now, taking out my calculator, I get that 15 squared is 225, and 17 squared, which I think I know what it is, but I want to make sure I'm doing it correctly. 17 squared is 289. I solved this like a regular equation. I want to get the b squared alone, so I bring the 225 to the other side. So that gives me the b squared equals, well, this is 464. But this is what b squared is, and we want what b is, so b is the square root of 64, which we happen to know is 8. So the answer is correct. Yes, Awa, that is what you got, and that was a correct answer, 8. Is that clear, Dion?
Yes, Professor. Thank you.
You're welcome. Okay, so now let's go back to what I was saying before. We would like this information that we've been using specifically deals with how long the sides of the triangle are. But we know in a triangle, besides being 3 sides, there also are 3 angles. Now, one of the angles we know has to be 90 degrees. The angles always come up in degrees in a triangle. When we're talking about an angle in a triangle, we talk about the angle in degrees. There are other ways to measure angles, but that's not within the scope of this class. We're just going to deal with angles in degrees. And we know that all 3 angles of the triangle have to add up to 180 degrees. Doesn't matter how big the triangle is, how small the triangle is. When you add up the degrees, because the degrees is just telling you how far open the angle is, it always adds up to the 3 of them adding up to 180. And then, of course, since we know that the C is 90, it means the A and the B together have to add up to 90 to make the total equal to 180. But we don't know specifically how big those angles are. And something that allows us to do that is the study of trigonometry. What we're going to be talking about today is the trigonometry of a right triangle. And it's the study of right triangles specifically related to their angles. Though it will, if you went far enough into it, it'll tell you a lot of other things, but that's where it started out. And what we have, and this is something we can only do in conjunction with our calculator, because our calculator is totally calibrated to that. We have 3 what we call primary trigonometric, which I'm just going to call trig values that we talk about. 3 of them. One is called the sine, S-I-N-E, which is abbreviated SIN. Each of these are going to be abbreviated to 3 letters. And if you look on your calculators, you'll see buttons with each of those 3 letters. The second value that we talk about is something called the cosine, and that's abbreviated COS. And the third one that we talk about is something called the tangent, which is abbreviated TAN. And each one of these values are figured out in a very specific way. Each one of them is a fraction that you get by dividing one side of the triangle by another. And let's start out by talking about sine. Now, if you notice, I will never just say find sine. I will say find sine, and either I'll say sine A or I'll say sine B. I never worry about sine C because that's a right angle. We already know it. But we will never just say sine, because what we're going to see is the sine is a ratio, is the fraction that we get by taking the opposite side and putting it over the hypotenuse. It's a fraction. Now, I'm going to put some numbers over here. This is an example of a right triangle. Suppose I told you, let's take one of our triangles that we just talked about before. I think we said this side was 17. No, this side was 15. This was a 15. We had that triangle. We had this side being the 17, and this side we had being the 8. Those were the 3 sides. We had side A, 15, side B, 8, and side C, 17. Remember, we called it a Pythagorean triple because these numbers, 8 squared plus 15 squared, does equal the 17 squared that we had done before. Now, if I want to find the sine of A, I locate angle A, which is right here. And if I look at angle A, there's one side that's going to be called the opposite side, and one side that's going to be called the adjacent side. And of course, there's one side that's going to be called the hypotenuse. In a right triangle, we always know the hypotenuse is the one that's opposite or across from the right angle. But the other 2 sides, one will be opposite to angle A, and one will be right next to it. If I look at the one that's opposite, that's the one that's across from it, it's going to be this one. The one that has the same name, because that's how we named it. If this is capital A, then the opposite has to be small a. Again, we said this is our hypotenuse. I'm going to abbreviate this. The third side, notice the A has really 2 sides attached to it. One is the hypotenuse. The other one is what we call the adjacent side. Adjacent means next to. It's not across, it's adjacent. What did I tell you if I wanted to find the sine of A? I have to take the ratio, the fraction I get by doing the opposite side over the hypotenuse. So for our particular example, the sine of A would be the opposite, which is 15, over the hypotenuse, which is 17. And here is the value that is the sine of A. Now, sometimes we don't want this it to be as a fraction. We'd like it as a decimal. So if I want it as a decimal, then I take out my calculator, and in my calculator, I do 15 divided by 17. Of course, it comes out to a very long decimal. Usually what we do is we round the decimal to 3 decimal places. This is, if you did it on your calculator, came out to be 0.882352941. Notice it keeps going on and on and on. It actually goes on and on beyond that, but we only want it rounded off. It doesn't usually come out to an exact number. We round it off to 2 to 3 decimal places. So I go after, here's 1, 2, 3. I want to stop right here, so I have to look at the number after that, which is 3. So we just leave that. So in decimal form, that would have been 0.882. Exact as a fraction, 15/17. Rounded off to 3 decimal places, the answer was 0.882. That is the first of our 3 primary trigonometric values.
Okay, Professor, next question for you. So if the number was 8825,
Then I would have made it 0.883.
got you. Thank you.
If it's 5 or more, you always increase it. If it's 4 or less, you leave it.
Okay.
So now let's look at, this was what we called the sine. Again, remember, I have to tell you the sine of which angle. I have to name the angle because I'm using these terms opposite and adjacent, and it really depends on the location of those sides relative to the angle we're looking at. Okay, let's go through the other 2 values, and then I'll give you a way of memorizing this. The cosine, okay, is the adjacent side over the hypotenuse. Which means if I wanted to figure out what the cosine of A is, I have to go to the adjacent side. Now here's my angle A, and this is my adjacent side. It's a good idea if you have your triangle to label it so you'll have all these values ready. We know my adjacent side is 8, and my hypotenuse always stays the same, is 17. In other words, the cosine in fraction form is 8 divided by 17. If we want that in decimal form, so I have to then do 8 divided by 17. And I'm getting 0.4705. I don't have to go further than this because I want to stop at 3 numbers. The third number is the 0. The number after it is a 5, so I would have to write this as 0.471 in 3 to 3 decimal places. This is the exact value as a fraction. This is the number in 3 decimal places. And finally, we have tangent of A. The box afterwards because I don't know how big my box should be. The tangent we find by doing the opposite side over the adjacent side. If you notice, each one of them takes 2 sides of the triangle and does a ratio, a fraction from 2 sides. So the tangent of A is going to be, here's my A, the opposite, which is 15, over the adjacent, which is 8. That's in fraction form. In decimal form, I'd have to do 15 divided by 8. which gives me 1.875, which would, it comes out to be exactly that. It happens to be 3 decimal places, so I leave it like that. It turns out the sine and the cosine always will start with a decimal point. They'll never have a number in front of them. It's less than 1. The tangent sometimes is less than 1, sometimes it's more than 1. In other words, sometimes it starts out with a number in front of the decimal point. So
how do you know when you're missing a number or you're missing a side?
No, I wrote it, 1.875.
I'm saying, how would you solve if you're not given the number for a side? Like say we're given A and B, but not C. How do you do that?
You tell me, could you figure out what C is? What did we start out before we even started with this? Didn't we start out with the Pythagorean theorem, a squared plus b squared equals c squared?
Oh, okay. Okay, yes, we did.
Why I started with that, because with that, you can always figure out the third side of the triangle. So really, to do this, all you need to know is 2 sides of the triangle, because then you can figure out the third side, and then you could do all of these. Okay, before I do any more, and we're going to do a few more, I want to give you what I call a mnemonic device. You might have seen this before, heard it before. A way of remembering, because the biggest thing is to remember what is the sine, what is the cosine, what is the tangent. Once you know what they are, you can figure them out from your triangle. So there's this famous word called SOHCAHTOA. SOHCAHTOA. What does it sound like? Somebody is soaking their toes. SOHCAHTOA. So you want a picture. In your mind, picture a freezing cold day and somebody coming in, their feet are very cold, so they put their feet in a bucket of warm water. SOHCAHTOA. How does that remind you? Okay, so all you have to do is remember this picture of coming in and soaking your feet on a cold day. Sine is opposite over hypotenuse. That's the SO. Cosine is adjacent over hypotenuse. TOA. Tangent is opposite over adjacent. As a matter of fact, what I would do when I would be taking a test on trigonometry is the first thing I'd come in and I'd write this out. SOHCAHTOA. So then I have all the information I need about sine, cosine, and tangent. Okay, let's see how this works. Okay, I'm going to erase this problem, and I'm going to put another problem on the board, and I'm going to show you how it works. I'm going to give you a picture that looks like this. Not putting any letters on it. I'm going to tell you this one is 84, and this is 100, and this is my right angle. And I'm going to give this name. I could either call it A, or I could also call it by this strange letter over here. This is not an English letter. It looks like a 0, but with a line through it. It is a Greek letter. Very often in trigonometry, we use Greek letters. Why? Well, because the Greeks were instrumental in developing the whole study of trigonometry. And therefore, a lot of the things that when they came about were written in Greek letters. And we continue that tradition, so to speak. So very often you may see a Greek letter introduced in this trigonometry discussion. There's one advantage to using that. Well, they only use the Greek letters when they're talking about an angle. So if I ask you to find, let's say, cosine theta, I know that theta has to be an angle. Remember, in our triangle, the capital letters were the angles and the small letters were the sides. And sometimes like a capital C and a capital and a small c might look the same. So if I said C, you wouldn't know if I'm talking about C the angle or C the side. If you would see the size of the angle, if one the letter, if it was small, you'd know it was the side. If it was big, you'd know it was an angle. But it could be a little confusing. But whenever I use these Greek letters, theta, this is, let me pronounce, THETA, is one of the Greek letters. There's an angle alpha, looks like a fish. There's a letter beta, it looks like a bee with a long tail. But the most common, it's like X is the most common letter used in math in the English language. Theta is the most common letter used in the Greek letter for math. Okay. That's just not important math information, it's just information that when you see it, it shouldn't floor you. Okay. I asked you to find the cosine of theta. Okay, now, remember, so cot is adjacent over hypotenuse. So the first thing I have to decide is what am I looking for? Which two sides? And we know that for cosine, we're looking for adjacent and over hypotenuse. So then we have to label. Here's my angle. Label the three sides. Now, the side that I always label is one that's directly across. This is going to be my opposite side. Obviously, this is going to be my hypotenuse because it's opposite. The ones that are opposite are direct across. And the third side, the second side that's attached to the angle, this one right here, that's going to be my adjacent. So now I've labeled my sides opposite, adjacent, and hypotenuse. And I'm going to show you in a minute why. Don't automatically put this opposite, this adjacent, and hypotenuse, because I'm going to do another problem that'll show you where that might be a problem. So I know if I want to find the cosine of theta, I have to do the adjacent side, which I see, I know what it is. It's 100 over the hypotenuse, which I don't know. And this gets right to your question, Dion. How do I do that? How do I figure that out? And because
when you put in the a squared plus b squared equals c squared.
Absolutely. I'm going to do a squared plus b squared equals c squared. And this would be my a because that's across. 84 squared plus b squared, that's 100 squared. Just, it doesn't matter how you put these. You can put the 100 squared first and the 84 squared second, but equal the c squared. It always has to equal the hypotenuse squared. And of course, now I'm going to use my calculator. I don't want to do this. Very important, if you have not gotten a calculator or you're not using a calculator until now, for math, it's essential for this topic and for the next topic. There are buttons on this calculator that you must use. We can't do it without those calculators. So 84 squared when I put it into my calculator, it gives me 7,056. 100 squared, I should know that without doing that, is 10,000. So if I add these up together, I get 17,056 is what C squared is. Now I'm not finished. I have to figure out what C is. So I do the square root of 1,756 on my calculator. And I get that C is equal to 130.5986. I'm not going further than that, which means I really could write this as 130.599 rounded to 3 decimal places. So the cosine of theta is then going to be 100 over 130.599. And they wanted my final answer. Let me just read what they asked for the final answer. They want the answer to 3 decimal places. So I'm going to do 100 divide by 130.599. And I get 0.76570. Remember, I want to go to 3 decimal places. So this becomes, this is my 3rd decimal place. This is higher than 5, so it becomes 0.766 would be my answer to what the cosine of theta is to the nearest to 3 decimal places. And this is given as a multiple choice question, and of course one of the answers was 0.766. So that's how you do a problem that involves the finding the sine, the cosine, or the tangent. I'm going to do 2 more problems with you, and then I'm going to give you one to try on your own. Okay, I'm going to leave that SOHCAHTOA on the board because we need it. Okay, I'm now erasing this triangle. And doing a little bit different type of problem. Suppose I told you that I know I have a triangle, a right triangle, and in that right triangle, the tangent of theta is 5/9. And I want you to find what is the sine of theta. In other words, they didn't draw the triangle for me. I'm going to have to draw a triangle. And I'm going to have to do SOHCAHTOA. So what information are they giving me? Here's my triangle. I know that we're talking about a right triangle, so let's draw it right here. And let's write here my theta. And of course, this is going to be my opposite side, because it's across. This is going to be my hypotenuse. And this is going to be my adjacent. Always, if your angle is over here at the bottom, the one that stands straight up is the opposite, and the one that lies down along the floor is the adjacent. And of course, the leaning one, the one that looks like a ladder leaning, is the hypotenuse. Now, what do I know about tangent? Tangent is TOA. So tangent is opposite over adjacent. So when I tell you that the tangent of theta is 5 over 9, it must mean in the triangle I'm talking about, the opposite side is 5 and the adjacent side is 9, because tangent is opposite over adjacent. Or it's some equivalent numbers. It could be, if this would be in decimals, I put it over 1 and do the same thing with the decimals. So if I draw my picture, on my picture, the opposite side is 5 and the adjacent side is 9. This side I've labeled as opposite, this is my adjacent. Now I want to find out what sine of theta is. And I know sine is so. So is opposite over hypotenuse. And if I look at this, I know what the opposite side is. I know the opposite side is 5, but I don't know what the hypotenuse is. But I can figure out what the hypotenuse is, because I know I can do what I did before. A squared plus b squared has to equal c squared. I know the opposite is, this is 5 squared. This is my b, this is 9 squared equals c squared. The missing side happens to be the hypotenuse. So I figured this out. 5 squared is 25 and 9 squared is 81. So it turns out when I add these together, I get 106 is c squared, which means that the c has to be the square root of 106. So if I go to my sine, so I'm doing the opposite side, and now I know this is a square root of 106. The opposite is 5, and this hypotenuse is a square root of 106. Now, two things. My answer is coming out to be 5 over the square root of 106. This is an exact answer in radical form. Sometimes they want the answer in radical form. If they do, they want it without the radical in the denominator. Remember, we have to rationalize the denominator. So I would have to multiply the numerator and the denominator by the square root of 106. And that will give me 5 radical 106 in the numerator. And of course, when you do the square root of 106 times the square root of 106, it just gives you 106. So in simplest radical form, my answer would be 5 radical 106 over 106. Sometimes they want it in decimal form. Let's say they want it in decimal form to 3 decimals, 3 places. So then I could just take this number and stick it into my calculator. And in my calculator, I will do 5 divided by the square root of 106. And it comes out to be 0.48564, etc. And again, I wanted 3 decimal places. So I'm going to stop after this 5. The next number is a 6. So rounded off, it would be 0.486 as my answer. So here's my answer as a fraction. Happens to have a radical in it, but it's fine as long as the radical is not in the denominator. And here's my answer as a decimal, which is probably the more practical answer if you want to use it further. So that's how we can go from knowing one trigonometric value, we knew what the tangent was, and we were able to go and figure out the other trigonometric value. In this case, we were able to find out what the sine is. Again, if you notice, it involves finding the third side of the triangle and then going on from there. Okay, I'm going to give you one to try now. I'm going to erase everything here. I'll give you a few minutes to try one on your own. Let's say I'm going to give you a picture this time. And I'm going to change it a little. Suppose my theta I put over here. And suppose I told you that this is 8 and this is 10. And I want you to find cosine theta. Don't forget to first label opposite, adjacent, hypotenuse, so you can do it. I'll give you a few minutes. Oh, by the way, I want the answer both in decimal form and in fraction form, both fraction and decimal. Okay, I think we can work on this together now. Let's say we want the cosine. Well, let's do it. Cosine. So cosine is adjacent over hypotenuse. So let's look at our angle. Our angle here is theta. And let's label our sides opposite, adjacent, hypotenuse. Okay, directly across is the opposite. Notice it's not in the same position. Usually we think this is adjacent, but it's not because the angle I'm talking about is up here on the top. It's not over here. That's why we always have to label what angle we're looking at. Cosine theta. Where is my theta? This is my theta. Then the 8 is the opposite side. Of course, this, across from the right angle, the 10, is the hypotenuse. And the other side that's connected to the angle, this side, is the adjacent. Just the opposite of what we had when this was our angle, then this was our opposite, and this was our adjacent. But that's not a problem, as long as we label it right away. Okay, now we know our cosine is the adjacent side over the hypotenuse. So I have to figure out what the adjacent side is. So again, I'm going to use my a squared plus b squared equals c squared to find my third side of my triangle. So this is my a squared, I don't know. This is my b squared, which is 8 squared. And this is my c squared, just to be, always be careful. These two, it doesn't really matter which you put first and which you put second. But on this side, always has to be the hypotenuse squared, which in this case is 10 squared. So figuring this out, this gives me a squared plus 64 equals 100. And if I subtract 64 from both sides, it gives me that, I'm going over here. Bring it over here, that a squared equals 36, and that very nicely comes out to the square root of 36, which is an exact number of 6. This number is 6. So now I can tell you that my cosine is adjacent, which is 6, over hypotenuse, which is 10. Of course, if I wanted to, I could reduce that fraction to 3 over 5. I could also, that would be, so I would say my fraction answer is 3 over 5. In other words, if you can simplify it. And your decimal, just do 6 divided by 10 is 0.6. And that's your answer. It's an exact decimal also. So that would be your answer if making sure that you have things placed in the right position. Okay, and that's perfect. I would really have changed that 6 over 10 to 3 over 5 because usually they do want the answer reduced. I'm just going to show you one other thing we could do with this. That involves using your calculator. I'm going to erase some of this work because we already have it and it's just making everything look very messy. And really, this is going to show you the purpose of doing this work. I think this is what you need to know about the three main trigonometric values. On Tuesday, we're going to talk about the other 3 that we sometimes mentioned, but I don't want to get too confusing now. Right now, let's stick with just sine, cosine, and tangent. What did we discover in this example? we came up with that the cosine of theta, this angle, in decimal form came out to be 0.6. Now I can use my calculator. On my calculator, and this is true of most of the calculators that you see, you'll see 3 buttons. One saying SIN for sine, one saying COS for cosine, and one say TAN, and that's for tangent. So we have these 3 buttons that have to do with trigonometry, with sine, cosine, and tangent. Now, what the button is going to do, one of the things the button can do is it can, if you give it a value for, let's say, the cosine, say we know the cosine is 0.6, it can give us, and this is stored in the calculator, it's not something I could figure out. It can tell you what angle goes with that. How do you do that? Well, above each of these is something, you see sine with a little -1, and this says cosine with a little -1, and this says tangent with a little -1. Obviously, the button we're interested in has to do with the cosine. But you don't press the button directly. You first have to press what's called the second button, or the alternate button, and then you press the cosine, and then you put in 0.6, and then you press equals. You do that on my calculator. Second, cosine, and it comes up with this cosine -1, 0.6, and I'll close my parentheses, and I get an answer that looks like this, 53.13010235. I'm writing the whole thing that I see there. You should get something like this when you press that button. What is that telling you? It's telling you how big angle theta is. Angle theta is, and this is in degrees. Now, if you don't get that answer, it probably means that your calculator is calculating it in a different measurement, not degrees. If you don't get this angle answer when you get it, just ask me and I'll tell you what to do with your calculator. But usually when we go to degrees, we go to the nearest degree. In other words, theta in the nearest degree is 53 degrees. So now, using trigonometry, we started out with 2 sides of the triangle. We now have all 3 sides, 6, 8, and 10. We know that this angle is our 90-degree angle. And we just figured out that this angle is our 53-degree angle. And I can figure out what the third angle is also, because I know since this one is 90, these 2 have to add up to 90 also in order to get all 3 to add up to 180. So I can figure out the third angle by doing 90 minus 53, which gives me 7, and this is 8, 37 degrees. And I have completely solved my triangle. I only had 2 sides of that triangle and a right angle, and I had 3 missing parts, 1 side and 2 angles, and I figured out all 3 of them. So we can use trigonometry. I don't think this is something you're required to know, but I did want to show you, you would have to know how to find the cosine, you would have to know how to find the tangent, etc. But I thought it was important for you to see the purpose of it, that it's not just vague and something, it really gets you to numbers that you can use in your triangle. Does anybody have any questions about this? Okay, so I am going to end the session here. let me remind you that next Thursday, there is no class because it's Thanksgiving. We will be finishing our study on trigonometry on Tuesday, and probably won't take the whole period. We'll finish up the trigonometry and then start the last chapter, chapter 8, the chapter that we have not done in our book yet. But we're basically at the end of the term, we're coming up to the end. As I said, I'm not exactly sure. I haven't gotten the schedule, the exact schedule, but it looks to me like our final is going to be the week of December 12th. It might be the 13th, it might be the 14th, I don't know. I'll have to be told that, but we have very short amount of time left. We have, besides this one chapter to do, so that's where we're up to. At this point, you should be making sure that you have done all the work on Delta Math and on all the tests that were given on Delta Math and on Blackboard. Everything should be complete. Your homeworks should be complete, and your tests should be complete. If some of the homeworks you did late and you got 90% instead of 100%, I will not count that against you. As long as your homeworks are complete by the end of the term, you will get your complete mark for the homework. Don't forget, your midterm was 25% of your mark and your final is 35% of your mark. Your homeworks and class tests and everything, and attendance and all the other things that I gave you to do aside from the midterm and the final, that will end up, that's the other 40% of your mark. Does anybody have any questions? Don't forget.
I have a few questions.
Yeah, sure. Let me see if I can answer them.
One question was about the email that I sent you about that specific problem. And the other question is, do you know exactly what date will be the final exam?
No, as I said, I don't know exactly. I think it.
Oh, I didn't hear.
I know it's the week of December 12th or 13th, that week, but
Okay.
I don't have the exact date.
And another question, sorry. Are you gonna give us multiple attempts, like 2, or is just 1?
On the final?
Yes.
No, the final is 1 attempt. It's the same way the midterm was given. That's how the final exam, it's a multiple choice test and you get one chance at it.
Okay.
Again, if you want it, I want to give it to you at a specific time so that I can be available at that time, so that if there was any glitches, like your internet goes down, and we know this happens all the time, I will be able to reset it. But I can only reset it in terms of, I can reset it if you have a problem with your internet.
Oh, okay.
Professor, you're also going to give us a practice final like
Yes.
we did with the midterm?
Absolutely. As a matter of fact, I'm going to do the same thing. I'm going to consider it a test. But if you do better on the final than you do on that, I'll exchange the marks.
Oh, so sweet.
Okay, but it's going to be, I want you, the practice final will consist of 40 questions, but the actual final is only 30. There's 30 multiple choice from the beginning of the term. Any other questions? Did you want to ask me the question on how to do that problem now, or do you want to meet with me Tuesday morning?
Can we do it now?
Sure.
Thank you.
Do you mind if everybody listens?
I don't care. It's no problem.
Okay. Anybody who wants to sign off at this point can. Anybody who's interested in this problem can listen to this problem. Can you have the problem? The other problem?
Do I have the problem? Not on me. Let me see if I sent it. for the email. Hold on.
You too, Akeem.
No.
If not, let me see if I can locate. I might be able to do it on my tablet because I don't want to go off of this program.
This is not it. All I know it was a division question. You done? Okay. I don't remember. It's okay, thank you. Well, I'm sorry.
I can find this. Da, 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 da.
It was the division problem. And for my answer, I had got 9. That's the only thing I remember.
Okay, I think I have the problem here. The question was 16x cubed minus 8x squared minus 19x plus 5, and we're dividing that by 4x minus 1. That was the question, right?
Yes, that was the question.
So let's remember how we do long division. This has to be in descending order, which it is, and there's nothing missing. Everything's okay. And we put that on the inside, and we put our 4x minus 1 on the outside. We do it like long division. Remember that?
Yes.
Okay. And then we take the first number, which is the 4x, and divide it into the first number. So the 4 goes into the 16 4 times. And the x goes into the x cubed. Remember, you're subtracting exponents, so this is 3, and the exponent here is 1. 3 minus 1 is 2. This is 4x squared. So we have to put a 4x squared on the top, correct? So far, okay?
Can you repeat that?
Yeah. Take just the first term, the 4x, and divide it into this first term, 16x cubed. So I take the 4 and I divide it into the 16. That gives me, and the x goes into the x cubed, x squared. I do the numbers separately and the letters separately. Can I go on?
You can move on.
Okay. Now what I do is I take this thing that I put on top and I multiply the whole thing by it. So 4x squared times 4x is 16x to the third, right? And 4x squared times negative 1 is negative 4x squared. I take it and multiply it first by the first term, then I multiply it by the second term. And then the next thing I want to do I had a colored pen, is I want to subtract. Well, if I want to subtract, this is really a plus, that's going to become a minus. And this, which is a minus, is going to become a plus. And 16x cubed minus 16x cubed, that just cancels. But here I have negative 8x squared and plus 4x squared. And a negative 8 plus a 4 gives me negative 4x squared. and I bring down the next term, which is negative 19x. Regular long division. I start all over again. I take this first term, 4x, and divide it into the negative 4x squared. Okay, so we do the number into the number. 4 into negative 4 is negative 1. And x into x squared is x. So this becomes negative 1x, or if you want to just write it as negative x, that's probably more accurate or more acceptable. Not more accurate, it's true either way. So we got this negative x, I just put on top, and I multiply it. Negative x times 4x is negative 4x squared. And the negative x times the negative 1 becomes plus 1x, because negative times negative becomes positive. And now I have to subtract again, which means I have to change the signs. So this one is going to become a plus, and this one's going to become a minus. And here I have negative 4x squared plus a 4x squared, which cancels out. And this is negative 19x minus 1x. And negative 19 and negative 1 is negative 20. So this becomes negative 20x. And I have to bring down the next number, which is plus 5. And I start dividing again. 4x into negative 20x. Well, the 4 into the negative 20 is negative 5. And the x's cancel out, because this is x and this is x. When we subtract their exponents, we're not left with anything. We're left with a 0. So we just put a negative 5 on top, and now we multiply by it. Negative 5 times 4x is negative 20x. Negative 5 times negative 1 is plus 5. And now we want to subtract, so we change the signs. This becomes a plus, this becomes a minus. And the negative 20x and the plus 20x cancel. And also the 5 and the negative 5 cancel. So I'm left with no remainder. And this is my answer, 4x squared minus x minus 5. Was that a help to you?
Professor, I'm so happy that that problem came up, because when you write in the answer, can you show us if there was a remainder, like say hypothetical, if there were a remainder, you had to write the answer. Can you tell us how to do that one?
Okay, let's say your remainder, so you would write this, right? And then you would do, let's say your remainder would have been 7. So then you would have done plus 7, and then you would have put your slash sign for division, and then you would have put your 4x minus 1. In other words, this would be plain, and only this part would be in the fraction. Does that answer your question?
Okay, because when we had this problem on Delta Math, and I was having some real issues figuring out how to put the answer into the answer box. So I would have wrote, if this was a problem, I would have written 4x squared minus x minus 5, and then plus, and then 7 over 4x.
At 4x minus 1.
4x times 1, right.
You have to probably put this in the parentheses. Maybe the best thing would be to put the top and the bottom in parentheses. You really don't need to put the top in parentheses, but that would certainly be okay. If that might, you know what, I'm going to go to the, first of all, number 1, on the final, and you will have something like this on the final, it'll be a choice. You'll be able to tell which is the right answer. You're not going to, so there are not going to be any more questions like this on Delta Math. So in case of, if you're worrying about this for the future, don't worry about it for the future. Is that clear?
Yes, that's clear. Okay.
Okay, I will.
No, you said, you said it's gonna be on the test, but we don't have to worry about it for our homework anymore?
So you have to do your homework. Now, if you get it wrong on the homework, it's still, your homework is considered done. I am gonna go back and look at it on the Delta Math and see if I can come up with a better way of telling you how to do it. But don't worry about it. Try the problems, but when you enter it, you get it wrong, it's fine. If I see something marked wrong, it means you attempted it. And it just means that you probably didn't know how to enter it properly. So then you get complete credit. I'm the one who's looking at the marks and telling. When it comes to a test, you're not getting complete credit for it. But on the homework, complete credit means do it. It doesn't matter if you get it right or wrong, just do it.
Okay.
Okay, I think class is definitely over.
Yes. Have a good weekend, Professor.
Good weekend, everybody.
Thank you. Have a good weekend.
Thank you.
Bye-bye.
Okay, bye.